Welcome to this insightful exploration into the world of sensors and actuators. I'm Ryan Chan, CEO and founder of Upkeep. In this video, we'll be stepping into the shoes of sensors and actuators and understanding their vital role in system operations. As we navigate through this topic, you'll gain a deeper understanding of how sensors monitor environmental conditions and how actuators respond to these conditions to carry out specific tasks. Let's get started by taking a closer look at how these components, sensors, and actuators function individually. First up, let's talk about sensors. Sensors are like the watchful eyes of a system, monitoring environmental conditions. This could be anything from the level of fluid in a tank to the vibrations of a ball-bearing system or even the temperature of a furnace. The input from the environment is converted to an electrical signal, which other pieces of equipment can interpret. Let's take a gas furnace as an example. In a gas furnace, there's a thermocouple that monitors the heat from the pilot light. As long as the pilot light keeps burning, the thermocouple generates a current. The greater the heat, the higher the voltage will be. Now let's move on to actuators. At its core, an actuator is a device that causes movement. It takes input, often an electrical signal, and energy, which it then converts into physical motion. An actuator could be pneumatic, hydraulic, electric, thermal, or magnetic. Consider a hydraulic cylinder on an excavator. This cylinder uses pressure from hydraulic fluid to push and pull on the piston rod within the cylinder barrel. This lateral movement is then used to move the arm on the excavator. So how do sensors and actuators work together? Let's go back to our furnace example to illustrate this. In furnaces, the gas shutoff valve is connected to the thermocouple. As long as the pilot light is going, the thermocouple generates a current, and that current keeps the valve open. If the current stops, say if the pilot light goes out, the valve shuts. This prevents gas from accumulating in the furnace and reduces the risk of an explosion. In this scenario, the sensor, which is the thermocouple, provides both the energy and the signal for the actuator, which is the shutoff valve. In other systems, the setup may be more complex with multiple sensors and actuators working together to perform a task. However, the basic principle remains the same. The sensor provides a signal, and the actuator adjusts based on that signal. Also, the movement from an actuator may register on a sensor, allowing it to control other components of a system or provide performance data for condition-based maintenance. So, there you have it. That's how sensors and actuators work together in a system. They're like a dynamic duo, with sensors picking up on changes in the environment and actuators responding to those changes to perform specific tasks. This teamwork is crucial in many of the systems we rely on every day. Thank you for watching this video. We've explored the vital roles of sensors and actuators in system operations and how they work together to monitor and respond to environmental conditions. Don't forget to subscribe to our channel for more informative videos like this. If you want to learn more about us and our services, please visit our website at upkeep.com. We have a wealth of resources to help maintenance and reliability teams be more successful.